Right, welcome back. Let's do question 13b, which is the last question for this pack. Right, a container has a capacity of 500 cubic centimeters. It is filled with water at the rate of x cubic centimeters per second. So the capacity is 500 cubic centimeters. Then the rate is x cubic centimeters per second. Right, and then when the rate increases to x plus 3 cubic centimeters per second, do you say centimeters per second here? No, it's cubic centimeters per second, okay? Right, so if when the rate increases to x plus 3 cubic centimeters per second, the time taken to fill up the container will be reduced by 40 seconds. Determine the original time taken to fill up the container. Okay, so what do we do here? So we have the time, the original time, and then we're going to have the time when after the rate has been increased. And then the difference between the original time and the time after the rate has been increased is 40 seconds. So now if you say the original time minus the new time, it should give us 40, isn't it? And then we create an equation, then solve. Okay, solve for x. Right, x is the rate. If you check here, even these units, they are guiding you. The units themselves are guiding you. So it means here the rate is what? The rate is equal to cubic centimeters divided by time. So it means it's going to be the capacity or the volume divided by the time. The rate is going to be the volume divided by the time, isn't it? So our rate is x here. Our rate is x. So it means here x, which is the rate, is equal to 500 divided by the time. You see that? Okay. So you can even cross multiply here x over 1 and then say this is tx. Okay, whichever method you're going to use to cross multiply, even a faster one, to see that t is equal to is going to be 500 divided by x is fine. It's fine. It's okay. So t times x. This is t times x. Okay. T times x. Let me put a dot here to show that this is t times x is equal to 500. Right. Meaning that our time, then time we divide by x. Time is going to be 500 divided by x. Okay, that's time. So for the time, we divide the volume or the capacity by what? By the rate to get time. So this is the original time. Original, how do you spell original? Original time. Okay, and then the new time is going to be how do I, let's say time new here is going to be 500, which is the capacity, okay, divided by the rate, which is x plus 3, the new rate. And then this is the new time. You see that? Once you've done that, we have finished. We have finished this thing because it's going to be this minus this is equal to 40. So we're saying original time minus new time is what? Must give us 40. So it's going to be 500 over x minus 500 over x plus 3 is equal to 40. Then now we just solve for x. And then what do we do? Okay, we know how to solve equations that involve fractions, and we use different methods. So you can use the method that you are familiar with. Okay, so what we do here, I'll say 500 over x, and then I multiply by the LCT. The LCT is x times x plus 3. Okay, right. So we may be using different methods here, so it's fine. Use your method of solving equations with fractions. And then LCT is x and then x plus 3. Okay, and then minus 500 then over x plus 3, then times the LCT x and then x plus 3, okay, is equal to 40 in times the LCD x in x plus 3, okay. And then this goes, this goes. You can do this in a faster ways, no problem. You see that? And then we remain with 500, then x plus 3 minus 500, and then x is equal to 40x. I'm going to simplify this. X plus 3 is 5. Okay, right. And then let's distribute here. Remove this bracket. It's going to be 500x plus 1500 minus 500x is equal to 40x squared plus 120x. You see that? Let's write our equation in standard form. Oh, there's something we can cancel here. 500x minus 500x is 0. So let's bring this one this side so that we can have our standard form. So it becomes 40x squared plus 120x. You see, I'm moving the 1500. So that's the one which becomes negative. Okay, and then equals to 0. Right, and then we can factorize this. What's the highest common factor here? We can, let's try to use 20. So it's going to be 2x squared 20 plus 6x minus 75 is equal to 0. Okay, right, and then here we have to use our quadratic formula. You have to use our quadratic formula. So it becomes x is equal to minus b plus or minus the square root of b squared minus 4ac, all this over 2a. So it becomes x is equal to negative 6 plus or minus the square root of 6 squared minus 4, then a is 2, then negative 75, all this divided by 2 times 2. Right, and then you substitute, you get your x. When you put plus here in your calculator and then also remove the plus and put minus, you should be able to get the two answers. So x is equal to 4,8 0 4 7 6 1 1 0 6, or x is equal to negative 7 8 0 4 7 60166. Okay, so now, and then we're required to find the original time. So which answer do we take here? Which x value? We take here the positive one. Okay, right, because it says when the rate increases, when the rate increases. Okay, so it means the rate is what? The rate is positive. Okay, so we discard this one. Okay, so now we put our x into this equation to get our original time, because it says determine the original time. So it becomes t is equals to 500 divided by 4,8 047 61106, which is equal to 104,06 seconds. Okay, done. That's what we're supposed to do. So we've managed to finish our examination preparation pack for this paper. So we're going to meet when we do the second pack. Thank you very much.